Hi everyone. Today we'll dedicate this session and lecture and video to revise some information, crucial one about data investigation from grade 7. So what we mean by data investigation? Normally we are talking about statistical issues and statements like we have to know that we have different types of data collection, first of all. So we should collect some data to to investigate about it. So what we have like types of data collection. We have a crucial, the essential one or census and sample survey. So normally a census, the different and the main difference between these two types are a census involves collecting information from every individual in the whole population. It is not practical. It is not practical at all. But if we collect data from a part of the population, we will obtain like sample survey about this, um, for example, study. Okay, and in the simple survey, we have a biased one and a random one. Biased one, when a biased sample does not truly represent the whole population, but a random sample is fair, it truly represents the whole population. So normally we should collect the data randomly from for example, a part of the population. Randomly is fair enough to have a like idea about the study that we are running. So, and we should know also for data investigation, for example, we should have a variable. We should have a question that we are seeking to have an answer to it. So normally, if we want to run a study and to begin a statistical or a survey, for example, we need to have a main question, okay? And we attend for answers as data. So what about the variable in statistic? We have different category for different type of variable, and we should know when the variable is, for example, a numerical value. Okay, a numerical or quantitative variable has a numerical value, but sometimes, okay, we have what we say as nominal or category variable that describe categories that are the names of things. Okay, for example, if we run a study about the most frequent names, for example, in Arabic, for example, or in a certain country. So normally the question is, what is your name? So normally the answer should be, or the variable here is nominal. But if we are talking, for example, about age of some population or some part of population, so normally here the variable is like age, so 21, 22, 23, so it is a numerical one, okay? And sometimes for the numerical variable, only for the numerical variable, we can also go further to ask about that type in details. The value could be discrete variables or continuous variables. For example, if we are talking about age, so normally we can also, for example, say 1, 2, 3, 4, 5, 6. Could be discrete. But if we are talking about continuous variable, like when we ask about the weight or the length of some population, so normally we can say that we are, for example, my length is 64.1 centimeter, or my weight is 41.5 kilograms. So normally so they are usually the result of measuring and lie within a certain range. What about the frequency distribution tables? So a frequency distribution table is a table that displays the frequency for each score. Okay, and sometimes we can calculate the percent of a score. It is equal to the frequency of the score over total frequency times the 100. So let's move on to start some exercises. State whether a census or sample survey would be used for each of these investigations. For example, the weights of the members of a football team. Okay, when football team, members of football teams, so normally the sample survey. The number of people who prefer vanilla ice cream, so number of people. So this is census because we are investigating the people in general. Pets owned by students in a class, part of the population. We are not talking about the number of pets, or for example, the whole population of a country, for example. So normally the sample, it is a sample survey. And what about the classification of variables as nominal or numerical? Hair color, so normally black, brown, okay, black, brown, or for example, a gray, so it is a nominal. The height of somebody, so it is in, or some buildings are numerical, and the distance is also numerical because we are talking about the numerical values. And what about drawing a frequency distribution table to show the following information? Normally, we start, for example, to the frequency distribution is can be classified as with two columns. It is a table of two columns or two rows. Okay, two columns with the first one is for the different data that we have in this list. And to be honest, it is more important, and it's more it is recommended to put this data in ascending order. So from the lowest 1, 2, 3, 4, 5 to the highest, which is equal to 10, for example. We have a 1 in this table, we have a 2, we have a 3, we have a 4, we have a 5, we have a 6, 7, 8, and 9, and 10. And the second column, we put the frequency of each data. So the frequency of each data corresponding to each data. The frequency, we mean the number of repetition of each one in this list. So normally 1, we have a 1, we have a 1, and we have a 3 times 1. So normally the frequency of the data 1 is 3. And so on to obtain finally total. The total is it is the sum of all frequency equal to 36. So normally the total frequency equal to the number of elements in this list, 1, 2, 3, 4, 5, and to obtain 36. Okay. How many numbers were 8 or more? 8 or more. So normally when we say 8 or more, could be 8, 9, and 10. The numbers, so the sum of its corresponding frequencies. So it is equal to 3 plus 4 plus 3 equal to 10. The number is 10. We have a 10 where 8 or more. Okay. What about stem and leaf plot? Normally, stem and leaf plot is usually used when there is a large number of numerical scores, okay, that are spread out. So, if there are more than 15 different values for score, the stem and leaf plot is very useful, and each score is broken into 2 parts. The leaf is the last digit of the score, and the stem contain all other digits. Okay, so normally with a stem and leaf plot, all of the data is used and displayed. The largest small measurement can be found, and the clustering of data can be easily see. The length of leaf row in the row indicate the number of scores belonging to that stem. Okay, so for example, we have this list of information, and we want to draw a stem and leaf plot using the stem 12, 13, 14, 15, and 16. So normally we put, first of all, in the first column, we put all the stem that we want to show, 12, 13, 14, 15, and 16, and we search for the number of leaf, the last digit. So normally each data here, it is like split it. We can split each data after counting from left to right after the second one. So normally like that. Okay, in this way. And we, for example, we search for the 12 here. So the 12, only we have a 12 like here. So normally we put the leaf as a 8. 13, we have a lot of 13. We have 131, we have 132, 132, 131, and 132 and 132. So put two times because 132 is repeated twice, and so on. Okay, to obtain finally 161 and the last data that we have. And we can draw also a column for graph for the data in this table. We have a different different way to show and to for example show the distribution of for example the different data that we have here. For example, when we are talking about a drink, first of all, we can say that we are dealing with categorical and nominal data and variables, because all these one are like names. And as a column, it's easy to, for example, put all the different types of drinks like that. And we can, for example, draw our column, and the height of each column represents, okay, the frequency of each drink, for example, each data here. So 18, I took, for example, as each small trace, each small one here, okay, like small step, like it is equal to 2, so 1, 2, 3, and 4, like a 1. So normally each we have a 4, okay, and we have the scale here is 4, 4. So normally it is a 4, it is a 4 to obtain a finally 8, and this is the height here, and we draw it easily. The dot plot is very similar, but instead of having column representation, we have a dot representation. So we should, for example, here draw and put 18 dots to represent the soft drink, and 10 dots to represent the frequency of corresponding to still water, and so on. Okay. Finally, we should know that about the sector angle. We should know that we have what we call sector graph. It is a circular one. It is circle. We draw a circle, okay? And then we use the semicircle ruler to put or to indicate the sector graph corresponding to each data that we have. First of all, we should, after having, when we have the frequency of each data, we can use, or we can compute, evaluate the sector angle corresponding for each data or for each frequency. How? We use this rule, the sector angle equal to the frequency times 360 over total. Because we know that the circle in total has a 36 degree as angle, okay, because we have a complete round, okay, so 36. So we should know that portion, the angle or the sector angle corresponding and representing each data. Using this rule, we evaluate each sector angle for each frequency, and then we can, for example, use starting point from here, and we count, for example, first of all, 112. So for this one, we have 90 degree, 112, like it is smaller than 180, like for example, 118. So normally, first of all, this sector is for snow fields. And we count after that from the terminal, for example, point that we have like here. We count using the semicircle again, 140 degree in this direction. So normally 140 degree, like we will obtain like here, for example. And so normally the second sector is for represent cold cost, okay, and so on. So these are the important information for today. Thank you for listening, and bye-bye.